This
version control.
conference will now be recorded.
Why do we need a version control system? Types of version control systems. This is how we'll proceed. So first, let us begin from version control systems. What is a version control system? Why do we need any version control system? Anyone have used any version control systems? Any idea of what a version control system does? Okay, version control system is nothing but if you look into a version control system, it can help you manage your files. To understand this better, let us take a scenario. Suppose there is a project. Let's say all the project work is kept here, all the remote, there's a remote location where all the project files are kept. Okay, there is a person, a developer A, who is working on it. Developer B also working on it. Suppose developer A has to make changes to, let's say, file1.py. Okay, he downloaded this file to the local computer. B also want to work on the same file. He also downloaded this file to his local computer. And both of them are making changes here. Then A kept the file back on day one. Okay, then B placed his file after making changes on day two. This is a remote location, a shared location which is shared by multiple developers or multiple DevOps persons. Okay, anyone if they are modifying those files, any configuration files. So day two, developer B has kept the file. Now, here file1.py will have which person changes finally? This is I'm talking about a scenario without using version control system. So which person changes will be there finally on this file?
Person 2 because it will overwrite the person 1's file.
Yeah, because only developer B changes will be there. What is happening? Developer B changes are overwriting developer A's changes. A does not know this is happening, even B does not know he is doing it. Correct? So if this keep on continuing, project gets messed up at some point, isn't it? You don't see the changes, it just gets messed up. Right? Like if it's in a team, there could be 10 people, right? If everyone is doing this, you know what happens to the project. So how to overcome this problem means how can we allow multiple people working on the same file. See, this is not only about developers. Visual version control systems can be used by developers, testers, DevOps teams, everyone will use it. Means if your developers, yes, it's mandatory for them, they'll have program files. Those program files could be Java, Python, C Sharp, whatever it is. The project files could be version controlled. Okay, even testers for automation testing, they do write some scripts. DevOps person do write some scripts. They have some configuration files which need to be version controlled. So whether you are a developer or a tester or a DBA or a DevOps person, everyone should know version control system to collaborate well. Okay, so what happens? We need a system which can allow people working simultaneously on the same files. It can allow people working parallelly on the same file at the same time. So if we don't use the system, it cannot be achieved, right? So with the version control system, we can allow people working on same file at the same time without getting overwritten. Not only that, we need a system which can provide detailed logging. Means, okay, developer A made some changes to file one. Uh, on 9th line, he made the changes on 6th February at 7 a.m. So this kind of detailed logging, including timestamp, is very important because if you have this kind of detailed logging, yeah, if you have this kind of detailed logging, if something goes wrong, we can revert it. We can put the situation back, isn't it? See, suppose till 6:30 application is doing good. Something went wrong, 7:30 application crashed. You want to see what happened in between so that you could revert those, you could remove those changes, isn't it? So this kind of detail logging, manually you cannot, that's not possible, right? To have this kind of detail logging. That's where again version control systems comes into picture, right? So it helps you have a detailed logging with a timestamp, which person made changes to what file and all, which is very important for the teams to collaborate. Yeah. And also, let's take another scenario. Suppose you are working on this file one, it's a version one. Client want to make a version two with lot of modifications. You have edited the same file and made a version. But after a few months, client came back and said they want version, isn't it? If new versions, latest versions are not doing fine, they may want to revert back to the previous versions. Correct? So how to go back to the previous version? Means you don't edit this file, rather maintain the backups, maintain the versions. Maintaining backups and versions, even all of them can be taken care by a version control system. Means whenever developer write the program, they put them in a version control system. As a DevOps person, yes, you do write some configuration files, some scripts, you can use the version control systems. So everyone should know how do you manage your files with the version control system. Okay, once this is done, means okay, you use version control system in two aspects. One is to manage your project files, to manage your code base. Second one is in the pipe. So first we'll talk about how to use version control system to manage your project. Then we'll also use it including in the pipe. Right? Everyone should learn it. This is very important tool in the modern DevOps projects. So that's a version control systems. Now, these version control systems, based on their architecture, were categorized as centralized version control system and distributed version control systems. Okay, and if you look into the centralized version control system, see there's a remote repository and there are some working copies. Means in the centralized version control system, there is one repository that's called central repository or a remote repository where all the project base, all the work is. And each developer, this is the workstation of each developer, developer 1, developer 2, developer 3. Each one will be connecting to this remote repository and make changes. Okay, they'll connect to this remote repository and make changes here. Okay, so that's how a version control system works. Let's suppose developer one have to make changes to some file. He will get the file downloaded to his local computer, make changes and put it back. Technically, these terms are called as like check-in and check-out, right? And so here there are some limitations or drawbacks. See, to connect to this remote server, always network connection should be there. You need to have network connection always to connect to this remote server, isn't it? If for some reasons there is no network connection, means entire work will be halted, right? So that's one of the problem with the centralized version control, because it works like a single source of truth. If network connection is not there, you have to wait till network connections are resumed, right? That's the first thing. And another thing is, yeah, see, because like I said, it's a central repository, it works like a single source of truth. If something happened to this remote repository, okay, said let's say the central server crashed, chances of recovery are very less. So these are the two limitations or drawbacks of this centralized version control system. Understood this architecture, everyone? Is this clear for all of you? Any questions?
No, man, go ahead.
Okay, so this is a centralized version control system, and to overcome these problems, we have distributed version control system. See here, distributed version control system is nothing but, see, this is a central server or remote server, and this is the workstation of each developer. Okay, this is the workstation of each developer, and this is a remote repository. So if you see here, yes, this is the central server or remote server. And if you see the workstation of each developer, every developer will have a copy of this remote repository, which is called local. Means every developer is having a local copy. Okay, that's why it's called distributed version control systems. So from remote, they'll copy and have a local repository. And then this is working copy means something like working directory. So first they work on working directory, then they move the changes to local, from local to remote. It's not that directly from working directory they cannot move the changes to local. This is the hierarchy that is implemented here. Okay, so first you have to make changes here, then move them to local, from local to remote. Unless you move your changes to remote, these are confined only for yourself. Okay, you can only see these changes. On remote, you cannot see those changes. Okay, they're confined for yourself. That's one thing. Another thing is how this overcomes the drawbacks of centralized version control system. It's because, see here, yeah, see, let's say there were no network connections. You can still work on local. You need network connections only to push to get from remote or to move to remote. That's all, isn't it? Unless you don't want to push or pull, you can still work here. Means entire work is not halted. You can still continue working on your local repositories. Got it, everyone? So network connections, even though you don't have, you can still work here. You need network connection only to pull. And you push and pull less frequently. Means once in a while, once all the changes are done, you pull, or else you get a copy. So these are less frequent. Most of the times you work with a local repository. Once every changes are done, everything is complete, then only you move to remote. Right? So you need network connections only here. Majority of the work is happening here. Local repository means it's on your same system. So it's just you need to access your hard disk. So it is also faster. No network connections required all the time. It works faster because majority of the times you work in local. Another thing is, even though this central server is crashed or lost, because everyone is having a copy of local, chances of recovery is also more. Got it, all of you? Chances of recovery were also more. So that is how the distributed version control systems work. No network connections needed. Means you need network connection only to push or pull. It works faster than the centralized version control systems. Chances of recovery are also more. Am I clear? Understood this much, everyone? So this is how distributed version control system works, and Git falls under this distributed version control system. Some examples of distributed version control systems are Git, Mercurial, Fossils. These comes under distributed. Centralized version control systems are SVN, TFS, Perforce. These are all centralized version control systems. So because distributed version control systems are very helpful, Git is very widely used nowadays in all the modern DevOps projects. So I believe you got a clarity on what a version control system is. Why do we need it? What are the different types of version control systems? Yes? So now let us proceed into Git. We have learned the architecture of distributed version control system in general, right? Now let's talk about architecture of Git in particular. Okay, so let us proceed. Yes, see here the graph, if you see, Git is very widely used when compared with other tools. Can you see the graph? There is a lot of difference. This is a Google trend report. You can also check the latest graph if you want. Git is very widely used than any other version control system. And also if you learn Git, you can easily work with any others. So now let us look into the architecture of Git. See, like I said, Git architecture, Git has a local repository and remote, right? So this is the local repository. Okay, and this is a remote. And here if you see, like we have a copy of remote repository, which is a local. Okay, this is the local repository. And yes, you directly don't work here. I mean, you directly don't work on here. Like I said, right, there's a working directory. You means imagine it's like another folder or another directory. So you make changes here, move them to staging. From staging, you move them to local. From local to remote. This is the architecture. And here you have to understand. See, you cannot directly again move changes from working directory to local. No, you cannot do that. What you have to do, you have to first move your changes from working directory to staging, from staging to local. But what is the staging area? Staging area is also called as index area. And this works like a layer. Okay, it's a virtual layer. It's not any folder or directory. It works like a virtual layer. Okay, you cannot just right away push changes from working directory to local. No, you have to move the changes to staging area, then only to local. Okay, it's like why do you need this? What is its importance? Its importance is it works like a preview, okay, or else a pre-check before your changes goes to local. Understood. It works like a preview or a pre-check before you move your changes to local repository. And from local, you push to remote. Once you place your changes on remote, others can see the changes. Others in your team can see your changes. Until then, changes are confined only for yourself. You could be a developer, it could be a Devops project, or else it could be a development project, whatever it is. So this is the architecture. And here let me tell you few important pointers which are very important. See, like I said, see, these changes will be, these commands will be learning. There are so many commands. So this is my remote repository, right? This is local. I'll copy from remote and create a local repository. This local repository resides on your workstation, your local computer. And this local repository can be created in multiple ways, meaning one way is, let's suppose, okay, it's a 6-year-old project is already running, I joined the team today. So you copy from remote and create a local repository. That's one method. Okay, that's where you use git clone first and pull and all. Commands I'm not teaching, commands we'll do on the lab. Another method is, assume that it's a completely new project, it's starting from the scratch, there's nothing on remote. So you can manually create a local repository, okay, develop the code base here, then push to remote. Means basically local repository can be created in two ways. If already project is existing, copy from remote and create a local, or else manually you create a local repository, develop it and then push to remote and make a remote repository. Okay, those are the two scenarios you can create a local repository. Understood? We'll look into both of them. Today we'll get started with this. This scenario will take up tomorrow. Okay. So yeah, from local means once you create a local, you can move your changes. Let me tell you few more interesting pointers before we go for the lab. I'm talking about working directory, local repository, or two physical directories, two different directories, right? Physically, they are one and the same directory or same folder. Then how come you say working directory and local repository? Logically, they are different. Means how logically they are different? Let's see. Suppose this is a folder. Okay. This is a working directory. The same is a local repository. But how? See, if I just created a file here, I have created a file here means it is set to be in the working directory. Okay, after means if you just place a file, it is said to be in working directory. If you place it in the staging area with git add command, it is said to be in the staging area. Then if you use commit command, then it is said to be in the local repository. Means basically it's in the same folder, but the way in what status it is makes the difference, whether it is in working directory or staging area or local repository. Understood this logic? Means working directory, local repository are one and the same, but logically they are different depending on the status of the files. Understood this? Any questions? Any confusions here?
By looking at this, we cannot differentiate between working directory and the staging area or local repo.
There is a command to check the status called git state. By seeing that, we can understand what is where it is. Just by looking at the file in the directory, you cannot.
So,
Any questions? Clear with this? So now, yes, we can go to our lab, we can install Git, we can start working with a Git now. Before that, any more questions here, let me know. Just understand two things. First, today we'll create local repository in our system manually without copying from remote. Means let's say it's a new project. We create local repository manually. We'll see the differences between working directory, staging area, local repository, how it works. We'll look into this part today. And once there are a lot many things to be done here. Once we learn that, we'll move to remote. Okay, so that's how we learn Git completely. So now, yeah, now that we understood the architecture, we understood what is version control system, distributed one, and we understood the architecture, let us install Git. See, you can use Git on any operating system. It works on Windows, it works on Linux, it works with Mac and so on. Okay, so you can install and use Git anywhere. First, I'll start with Windows. Okay, we'll be installing Git on Windows and we'll do the hands-on. On Linux or on Mac, Git commands are same, whatever be the operating system. Installation may be different. We'll see installing Git on Linux also as we go by. First, let us install Git on Windows and start hands-on. Git installation is very easy, like you do in Windows. Any software, like how you install in Windows, the same way. Just to Git download. Okay, you can see the official documentation Git SCM. Okay, here if you go for Windows, right here, click here to download. Okay, or else according to the operating system, you may install it on Linux or a Mac, whatever you can. Okay, it's very simple. This is the official documentation of Git, which you can use for any references. So go here and click here to download. I have already downloaded it. Once you download the exe, run the exe like you do for any other software. Okay, once you run the exe, one second, yeah. So once you run the exe, you can see a wizard open, like you can hit on continue to see the next steps. There were screenshots available. I'll share the Google Drive where you have all these steps. All these links, everything were there. This drive I'll share with you. For all the registered students, this drive will be shared. See, download the latest version of Git from here. And like this, you will see a wizard open. That's all. That will install Git. It's very simple. And once this Git is installed, there is also something called Git bash will be installed. It provides some, yeah, it provides some bash environment to run Git commands. Okay, so see, like you have command line in Windows, right? It provides some bash environment to run Git commands. Now, before starting Git, I would like to show you something. Rather than using the GUI for Windows, we shall use command line because that is preferred approach, because Also in few classes, we are going to step into Linux where you have only command line. You don't have GUI for Linux, right? So let us go with some command line experience. Let's go through very few commands. See, in a Windows, if you want to open a directory, you just double click and go there, right? So in Linux, how you can do that? CD means change directory, the path where you want to go. Okay, maybe you might be aware of this, but let me just quickly walk you through few things. Okay, see, it says PHP. We are in the PHP directory. Let's suppose you want to go to the some downloads folder. Okay, just copy the address, paste it. Okay, so here you can see if you want to see in which path, which directory you are in, present working directory. Okay, it gives you the path, right? So that's one thing. And let's suppose I just want to go to this desktop, copy the address in this git bash. CD means change directory. This is how we work, isn't it? From the command line in Windows. So I just prefer this approach. This is how we use in Linux also. So where are we? Present working directory. We are in the desktop. So now on this desktop, for better understanding, I'll also show you this desktop at the back end. So this is my desktop. So now if I want to create some folder here, if you're using GUI, you just right click and see here new and you do this way, right? But how do you do it from here? What is the command? Anyone here? How to create a directory? mkdir, okay, means make directory. Directory means folder. Let's say I want to create a directory called git demo. Okay, you can see at the back end. Do you see in the GUI? There is a folder called git demo. Okay, and now go to git demo. Okay, you can see here we have gone through git demo. Again, if you want to create a files here, right click and you do that, right? The same thing can be done here. These are very simple commands like cd command, pwd command, make dir command. These are all the Linux basics. Anyway, I'll teach you all this again in a separate session, but just get familiarized using this way. Okay, now here
Madam, voice is breaking, I suppose.
is it okay now?
Yes.
Okay. So if you want to check the version, git version. That will help you check the version of the git. Okay, now, okay, git is installed. I want to version control files in a particular directory. Let's say this is the directory I want to version control. Means I want to version control all the files in here in this directory. Clear will clear the terminal. And so in this git demo, what files and folders are present? ls. ls means it will list all files and folders present in this directory. Okay, now, okay, I want to version control a file. So let us create here a file. A touch command will help you create a file. File1.txt. Okay, see here at the back end, do you see that? See, you can create any files. It's a Python program or whatever you can use. I'm just using a simple text file. Okay, create a file. Now, I just want to put some content like echo file1.txt. Okay, so some lines were created and we have some file. So now, where is this file actually? Can anyone tell me? Is it a git, actually, is it a git local repository? Not it. This is just a normal directory. If you want to version control this directory with git, it should be a local repository. So how do you create a local repository? How do you tell git to version control all the files in directory? With a command called git init. Git init means initialize git, start git. Okay, so that this git demo directory becomes a local repository and it can track the files, version control the files in that directory. See, initialize git. See, whenever you do that, a hidden .git directory will be created to see all the hidden files. -al. Okay, it will show you the hidden file. Okay, you can check from the command line or from the GUI, whichever is comfortable for you. I'm showing you both. So just let me clear this terminal. Okay, now yes, Git is version controlling now. So let's check the status. See, it tells that there is a file, means Git know there is a file called file1, but Git is not tracking it. Git could not track it. Why Git cannot track this file1? Because there is a file. It can track it. It is also giving you a clue. See here. It can track it. So first add it so that it can be tracked. Means always relate this to this architectural diagram. It is asking us to add the file. Means where is the file now? Currently, where is the file? Is it in a working directory or a staging area or local repository?
Working directory.
Sorry?
Currently it is in working directory, then we have to add using git add, then it will move to staging area.
Yeah. Yes. So it is in the working directory. So this is your working directory. See, untracked file. Okay, it is asking us to add. Okay, let us add it. Git add file1. Now tell me where is the file? Git status will tell you. Changes to be committed means where is this file? Changes to be committed means where is this?
Staging area.
That's all. It is in the staging area. And here, go to git bash. Yes, it is in the staging area. Now I'll say git commit -m. M means message is mandatory. For a commit, you have to put this message. Okay, git commit -m and git commit -m some message. Let's say first file created and all. So now if you check the status, it says it is clean. Means where is the file now? Clean means whatever files you have here were added to the local repository. ls will list the files in a local repository. Git ls files will list the files in a git ls files will list the files in a local repository. ls will list the files in a working directory. This is the architecture. This is how you move the changes.
So ma'am, first we have to download git and open git bash. So in git bash we have to run these commands.
Yes, you can have to run these commands in the git bash. Clear all of you? Any questions from anyone? Okay. Let us repeat this with another file so that things should be more clear. Yeah, let us repeat this with another file. Let's say I'm creating another file. You may use a GUI also. I prefer this. Let's say I'm writing some line. Echo means actually what echo command does is it's like a print. Hello is printed. Now this output I am placing into file2. This is called redirection operators. We'll learn that later. What is this and all? Just understand output of this one I want to place into file2. Means I just want to put a hello in this file2. So okay, now if you open this file2, how do you open from the command line? Cat is a read command. It will show you the content of the file. Like you do this way. You open the file this way, right? So what is there in the file? Hello. Okay, the same thing can be seen this way in Linux. All this commands list is also in the drive. I'll share you the drive link. Okay, so yeah. Now I have a second file. ls means, like I said, it will show the files in a working directory. Where is this file to? It's in the working directory. I want to see the files in local repository. Do you see there? File 2 is not listed in the local repository. Got it, all of you? So now what shall I do? If you see git status, what would be the status message showing us?
We'll have file 2 to commit.
Sorry?
File 2 is
Yeah,
not
file 2.
committed.
No, not commit. It will tell you, where is this file to? Tell me first. Always keep this architectural diagram in your mind, relate to
Working.
it. It's in a working directory. It's in a working directory. So if you do git status, say untracked, because git know there is a file, but git cannot track it because it's in the working directory. What we have to do? Git add file to, correct? So add the file. Now it asks us to commit. See here, changes to be committed. Means now file 2 is in the staging area. So what you have to do, git commit -m, let's say second file or whatever. Now it is in the local repository. You can clear the screen. ls, both are there in the working directory. Git ls files. Okay, means that's a logical partition or logical separation from working directory to local. It's one and the same. Git demo is your working directory. Okay, git demo is nothing but your local repos. Both are same. This is the justification of what we discussed some time back. Got it, all of you? Yeah. So if you are very comfortable with these basics, you can understand advanced concepts in Git very easily. Like from working directory to staging area to local, from local to remote. Okay. Got it, all of you? And now, yeah, let us look into one more thing. See, we have done commits, right? I have run the commit command twice. If you want to see the history of the commits, you can see git log. Okay, that will show you the history of commits. See, I have committed twice, including the timestamp. I told you, right, logging is there, including the timestamp and the file name which modified. And see, every commit will generate this unique hash code. It's called commit ID. A unique commit ID will be generated. Okay, every commit will be generating this unique commit ID. Okay, you can see the complete history of commits with the git log. And you need not use the entire commit ID. First 7 characters are enough. If you want to see only brief log, git log one line. See, only first 7 characters and the file and the commit message. We have given some message if you remember, right? Git commit -m. So this will help you. Okay, like -m means some message, right? So git log one line and you can see the commit messages and the commit IDs. These are the basics. Initially, when you are learning Git for the first time, there might be a confusion in like how to use what is this Git commit, Git add and all. But as we progress, things will be in place. Means you need to do practice. See, Git add we have used, Git commit we have used, push, pull and many other commands will be. But you need to understand this architecture. This is important. Okay, from working directory to staging to local. It's one and the same directory, but that's how we have logical separation. And till now we were still working on local. We didn't go to remote. We'll go for remote repositories as well as we progress. And yeah, here is the folder. If you want, you can see this way, or else you can also do this way. And here I would like to introduce you something else. Here, see, These files may be Python programs or Java programs or PHP programs, or else if you are a DevOps person, from our end, these files could be some Ansible configuration files or Terraform config files or whatever. Okay, there might be some Jenkins file, whatever. Okay, so these could be anything. Okay, if you want, you can just create a file with the text editors, any notepad and all. But there is also another good editor to use for our configuration files for Ansible and Terraform, which is Visual Studio Code. Okay, you can download this editor. That is nothing but an editor. Okay, don't worry, don't get confused. It's not just an editor. So you can just download from here. Visual Studio Code. Okay, even this download link is available on the Google Drive. So you just click on download and run that. That's all. Say I have already installed it. Okay, these are some Kubernetes configuration files which we are going to use as we progress. Okay, in the beginning you will just see a fresh one. Go to file. Here you can open our Git folder. Where is this? This one, right? Git demo. Say file 1, file 2, text file 1 is having 2, 3. So instead of using touch or writing this way, you can create files here. Suppose I just want another file. I may create like this file 3.txt, just an editor. Okay, I don't want it. You can just delete it. Understood everyone? Any confusions? Don't get confused please. Okay, this is just an editor. And this is my git bash. If you want, you can also open git bash here. Terminal. Okay, launch the new terminal. See here. In Windows, you have CMD command line, right? PowerShell you can open, or else here you can choose. I want git bash. So, okay, like we have here, you can also use it here itself instead of going there. Okay, you can run any commands, git status. Understood everyone? So just an editor to manage your files, because now I am using some sample demo files or dummy files like hi and all. But like I have just shown you, right? See, we have to version control some Kubernetes files like this. Okay, I want to store these Kubernetes files in the Git repository. So how do you do that? Here you can go for git bash, okay, to this directory, git init, and push them to remote. This is the real practice. First, I'm showing you Git. We are learning Git with some sample files. Later on, we'll use the same Git to configure to manage our Kubernetes files and so on. Hope you got an understanding of how we use Git. So just go to the terminal of git bash. Okay. So now let's come back. So git status, it says it is clean because whatever changes we have added. Let us look into another scenario. See, till now we have seen creating new files. Sometimes it could be modifying the file also, right? It's not always about creating a new file. So let's say I want to modify this file 1.txt. Oh, sorry. You may open here VI editor. I'll teach you VI editor later. Or else for now, let us use this editor. Okay. Suppose I am adding a new line. New line added. Save this. Okay, once it is saved, check the status. See, it will not tell you like untracked. Untracked means if it is for the first time. If it is a completely new file, it will be untracked. But it is not a new file. It's already there in the staging area and local repos, right? So changes to be committed, changes to be staged, changes are not staged. Entire file, if entire file is not staged, means if it is a new file, it will tell us like untracked. But if it is not a new file, so it just tells you changes not staged. So what you have to do again, see here. Again you can do git add file1 and git commit, add and commit, git commit -m. Okay, this is what you should do. Or this is, you can do add and commit separately, or else you can also do add and commit with a single line. Git commit -a means add and commit. You can do either ways because it's not a new file. But if it is a new file, you have to do only like this separately. If it is not a new file, you can do this way, or this way is also fine. Understood everyone? Got the difference? New file means you have to do add and commit separately only. It's not a new file because it's already there in the staging area and local repository. Here what you can do? You can do git commit -a -m and let's say file modified. Okay, now you can check the status, right, on branch master. Got the scenario, all of you? So this is how you can make changes to the file. So we have seen creating a files, modifying it to files. Let us take up another interesting scenario. I'm going to create a new file. You can create from here. File3.txt. Let's say a new text file. Save it. And I would like to, what would be the status now? I'm just repeating. We have already done this. So what would be the status? I would like to hear from you. What will be the status now?
File 3 will be shown as not committed.
For the first time, it's a new file. It will be untracked, right? See,
Yes.
untracked because it's a new file, untracked. We have to add and commit. So I'm just adding this file3. Okay, then after this status would be like, you should understand the status messages. It tells you like changes to be committed. So git commit -m and you have let's say new text file. Okay, done. Like just added another file. You can check the status. It was all clean. Okay, good, perfect. So now what I want is I would like to modify this again. We have done this also, modification. So okay, let me modify from the editor. Here another new line added. Okay, so now tell me one thing. Changes also we should add and commit. Tell me one thing. Is this file having any unstaged changes or not? File 3 having any unstaged changes or not?
No.
Is it not having any unstaged changes? Just now we made some modifications. Where are those modifications? Isn't it? We
Yeah.
just made some modification, isn't it? This file is having some unstaged. Not staged means unstaged. So if you want to see the unstaged changes of the file, git diff file name will show you the unstaged changes of the file. See here, unstaged changes of the file. Okay, right? Diff file name will show you the unstaged changes. Okay, fine. I'm adding the unstaged changes. Now tell me, is the file having any unstaged changes now?
All the changes are
No,
committed.
right? I just have staged them. It's not having unstaged changes. So see, no output when you do git diff because no unstaged changes. But this file is having staged changes now. Am I correct? To see the staged changes, git diff staged. It will show you the staged changes of the file. See here. Okay, staged changes because the same change is staged. Okay, this file is having only staged changes. It's not having unstaged changes. But I would like to make a modification again. Okay, now if you see status or else this is having unstaged line, right? Third line is unstaged. Am I correct? So please keep muted, Suraj. Git diff file 3. Yes. Do you see here? Right? Git diff file 3 that is unstaged and git diff staged means the same file is having staged changes as well as unstaged changes. Do you notice that? This is staged. Second line is staged. Third line is unstaged. Understood this, all of you? Simple logic. Yeah, simple logic. Some changes were staged, some changes were unstaged. So means this file is having both staged and unstaged changes at this point of time. At this point of time, if you check the status, see, you can see the same file. Changes to be committed means where is it? Changes to be committed means where is it? Changes to be committed means in which area is the file?
Staging area.
Staging area, right? It is in the staging area. Changes not staged means in which area it was? Changes not staged.
Staging working directory.
Working directory means, see, file 3 is shown as staging area, same file 3 is shown in the working directory. So whenever you see the file in both areas, don't get confused. This could be the reason. Means some changes were staged, some changes were not staged. Got it, all of you? Yeah. So now what you can do, you have to add and commit. You can do add and commit separately or else git commit minus a minus m file modified. Okay. So now everything will be added and committed. Understood, everyone? So just go through these commands and let me know. Understood the scenario? Shall I provide a recap? See, let me write what I did. Actually, what we did is, see here. First, we have one file. Okay, file 3. It is already committed file. Then what I did, I modified this. Modified file 3 means unstaged changes are there. Okay, then I have staged them. Okay, so yes, staged changes are there. Then again I have edited. Means there is some unstaged change. After this, I didn't add. Understood? Staged them means here what I did, here I have done git add. So staged changes and I made a change but I didn't add. So unstaged changes. Both the staged and unstaged changes are there. Means it's all about how you are modifying the file, because see, when you are working on it, you might be modifying many things. You might be doing so many modifications, right? So this is what the scenario is. Is the scenario clear now? You can unmute and speak out or else message in the chat window. I want everyone to follow the class thoroughly. If you are good with these basics, you can use Git very easily without any struggle. Am I clear? or should I repeat anywhere else? Thank you for confirming, Guna. Any questions from anyone? So today what we discussed what is a version control system. Okay, we have discussed types of version control systems. Then we have discussed the architecture of them, particularly Git architecture, right? And then we have seen what is a working directory, what is a staging area, sorry, what is a working directory, staging area, local repository, right? If you have a good understanding of this architecture, yes, you can learn the other advanced concepts easily. I'll provide all these commands, whatever I have used will be there in the Git drive. Okay, I'll share the Git drive. Send me your email IDs in WhatsApp. Registered students can send me the email ID in WhatsApp so that I'll share these drive links and the recording session will be shared. And yeah, that's all for today. We shall continue from here tomorrow because it's just beginning. First, set up your lab, install Git, get all this Visual Studio Code, Git Bash installed. Any help required, you can message me in the WhatsApp. Soon, WhatsApp group will be created to post all your queries. Until then, you can post me directly. Also, get all this setup done. We'll proceed into branching, merging, rebase, lot many advanced concepts in the next class. We didn't go to remote repository set. We were just working on local. We were here. And this PDF will be also there in the drive for your reference. This architectural diagram is very important. So any more questions from your end? If no questions, we shall wind up here and we'll continue tomorrow. All right,
Okay,
then bye.
thanks.
Everyone. Thank you all for joining. See you all tomorrow. Yes, if still you have questions, let me know.